This is Project 22 of Hacking with Swift. We're going to work with iBeacons, a fabulously cool micro-location technology introduced in iOS 7 that's since seen huge take-up inside shops, inside museums, galleries, hotels, all sorts of places. Don't worry if you haven't got an iBeacon on you. We'll be using an iPad to simulate an iBeacon using a free app from the App Store called Locate Beacon, or any other iOS device is perfectly good. For more information, see the website hackingwithswift.com. There you can buy this video and all these videos in the series in fantastic high resolution or as downloadable ebooks, starting at just $3 per shot. It's super cheap. Your support does help me make more videos like this one, and it's much appreciated. For more information, you can also follow me on Twitter. I am at 2straws. If you have problems, questions, feedback, suggestions, complaints, who knows what, get in touch. Follow me there at 2straws. I'll do my very best to help you. Okay, let's kick off. Launch Xcode, choose Create a New Project, then choose Single View Application. Give it a name. I'll choose Project 22 because this is indeed Project 22. Swift and iPhone is good. Press Next and Create. Okay, this is our first project that requires deployment to an iOS device that supports iBeacon, because sadly the iOS simulator does not support iBeacons. We can do about half the code for this thing entirely inside the simulator, which we will do, and then move to a device when we're ready. I do suggest, like I said already, have one device plugged into your Mac you can deploy to, and then another device simulating an iBeacon using Locate Beacon. You may find, by the way, that your device is down as ineligible, which is mine is right now, because I'm actually running Xcode 6.2 Beta 3, which is targeting 8.2 by default, and my phone only runs 8.11 right now. So I need to knock that deployment target down to 8.0, like that, and then becomes eligible, which is good, so I can deploy to my phone correctly. And I'll press play now, so you can see it running on my phone. Nothing that exciting. It builds slightly slow, as you'll see when you build to a device, because it has to actually copy across all the Swift standard libraries and stuff. It's a bit slower, but that's alright. Once it's done it the first time, it's a bit faster. So you'll see it running on my device. It is the standard built-in boring project template we've had 1,000 times so far. It's whinging because I have not told it to trust my computer. I'll press trust. There we go. There it is. What a brilliant project that isn't. That's okay. So what we're going to do is kick off by requesting location from the user. Now, location is something that is obviously very sensitive to the user, and it's got even more sensitive inside iOS 8, because location is now split into two categories. Do you want to use location only when your app is in use, or do you want to have location always, even when the app is not in use, which is obviously helpful for background tasks. For iBeacons, generally you want always, because you can actually ask iOS to look for beacons even when your app isn't running, and wake up your app when it finds a beacon. This is called region monitoring. In this particular app, we're making an app to look for beacons and say how far we are away from them. And in this particular case, we don't need always. We can use when in use. It doesn't really matter. I'll add support for both, and you can choose your own later. The first thing to do is to open up supporting files and then choose info.plist. This is your property list for your application. Now we need to add two keys to here, and these keys have to be typed in by hand. They're quite long. And both of these keys provide information to users to clarify why you want their location. So select something and press this plus button here. Then type in ns location always usage description, like that. I'll make it a bit bigger so you can see what it is. Boom. ns location always usage description. Then I'll add another one, and it'll be ns location when in use usage description. And obviously this is shown when you ask for always location. This is shown when you ask for just when the app is being used. And this text attached to it is very important. You can explain to the user what you intend to do with their location. So I'm going to write in here, we want to measure beacon distance. Brilliant. That, I'll put it in both of these. You only need one of these. You can actually use both. You can start with when in use and then upgrade to always later, but broadly you'll choose one. There is a slight difference between the two in the way the user sees them. Always has, I think, a fairly terrifying message on the screen. The users will go, wait a minute, this sounds very suspicious. And always also asks the user again after a few days, do you still want to give this app permission to have your location even when it's not running? So let's get moving on with some actual work here. Choose main.storyboard to open up interface builder. I'll make my screen a bit bigger. There we go. Make a bit more space for that thing. There we go. There's my view controller. I'm going to draw in there a large label like that. Make it nice and big. I'll write in there all caps unknown, because this app will show how far away my iPhone is from my simulated iBeacon, which for me is an iPad. If you have an actual iBeacon, all the better. And it'll show either unknown distance, I've got no idea where this beacon is, literally can't see it. It'll show far, it's somewhere in the vicinity, but I'm not sure how close it is. It's a long way, basically, up to 50 feet. Near, which is usually about 3 to 4 meters, so 3 to 4 yards. Or it'll show right here. It's literally inches away from this device, which is obviously very good for things like touch to pay or touch authenticate, because it's very, very, very close by that point. I'm going to give this font a different font, a real iOS 7 style font. So we'll say custom and Helvetica Neue style thin, super skinny, and then for a size, I'll enter 40 points. So super big and super skinny. Center align it. Then I'm going to align it using the blue alignment bars to the center of the view controller, and I'll control drag upwards to say center horizontally, then control drag left to say center vertically. So that will now stick in the middle of the screen no matter what. There are some orange lines going on here because the label is too big for the space allocated for it is too big for the label. So I can click on the pin menu and say update frames to make it resize appropriately so it fits the text. I'm now going to use the assistant editor to make an outlet for that inside my view controller. So I'll control drag from the label, down to my view controller here and give it a name. I'll say distance label. And we are done with the storyboard. So go back to the standard editor and press viewcontroller.swift so we can edit it full screen. Fantastic. So the first thing to do is request location access from the user. We already added those texts to our property list, which means there's some sort of text in there for iOS to use. We can now actually begin the work to make that happen. And that's done with a new class called CL Location Manager. This handles all the information about location coming in and passes it on to its delegate, which will be us, when things happen. So if the location changes, it will tell us why. So we can put in here, var location manager is a CL location manager with implicit unwrap like that. It will whinge because core location is separate to UIKit. So we want to say import core location above import UIKit. Then the interesting stuff in view.load. We want to create the location manager first. So we say location manager equals CL location manager, like that. Then we'll say make us the delegate of the location manager, which will of course complain because we are not compatible just yet. We don't conform to it. Then we're going to use one of two methods. You don't have to use both, just use one. Either request always authorization or request when in use. Now the help for this is actually wrong. Request permission to whenever the app is running. This is not true. Actually, it works in the background as well, as in literally the app doesn't have to be running. It will with iBeacons. It will let you do region monitoring as well. So a user walks into a thing when the app was not running. That was something you were looking for. This will trigger your app to launch. So I'm going to use when in use. Actually, I'll use always. It's fine. Just to show you the terrifying message it gives you, so you know it's a very serious thing. Then I'm going to further add, say, view.backgroundColor equals UIColor.grayColor. This is because, along with the label changing between unknown, far, near, and right here, I'm going to change the background color of our view to be a different color. So the user notices they're getting warmer and warmer as they walk towards a beacon. This is a fun sort of beacon treasure hunt app, ultimately. Now we have a error here because we aren't conforming to the CL Location Manager Delegate protocol, but that is as simple as saying comma CL Location Manager Delegate in our view controller definition, and that's it. There are no required things in there. You can go ahead and run that. I'm going to run it on my phone so you can see what it looks like. Let's unlock my phone and press play for that. It's still thinking. Run. Brilliant. So you'll see a large warning saying, do you want to give this thing access? Boom. So now you can see what actually happens here. This Xcode help wasn't particularly helpful. Request always. So request permission to use location services when the app is running is what it said. And now my iPhone's telling me, do you want to allow this thing to access location even when you are not using the app, which is clearly going to worry users. So use it if you need it. Otherwise, use when in use, because it's much less scary. I can press allow on my screen to allow that. And you can, if you use a simulator, actually, this will work in a simulator as well. At this point, it'll still work now. So I can go ahead and say run in iPhone 5S instead in the simulator, and I get the same warning. This bit obviously works entirely the same in the simulator or not. The advantage to the simulator is that it's very easy to say, oh, I want to try a different scenario. I want to press, don't allow or allow, or don't allow, then allow, who knows what. You can go to iOS simulator, then reset content and settings here to try again with a clean simulator. So I'll do that now. I'll stop project. I'll reset the device like that. I'll say, actually, what does when in use look like? Boom. And now I can run it back with when in use. And again, see what it feels like. The warning is much less terrifying. While you use the app. Yeah, that's sure. I'm using the app. Of course it can. Great. Allow. And that's it. We're showing a grey background thing with some black text saying unknown. Nothing interesting there. That's because we aren't doing most of the work yet. Now, if you did not see that message, do you want to allow location access? It means you did not type one of these two plist keys correctly. So please check the exact text of this and make sure yours is exactly the same. NS location always usage description, or NS location when in use usage description. If it did not see the warning, it means it was not typed correctly. You must have the right one for your method call. You can have both like I do, but you need to have the right method call in there as well. So, requesting location authorization is a non-blocking operation, which means you say, give me access. iOS shows that the user information. Do you want to allow or not? They press allow, and you get a call back when we know what's happened. So we can actually use a delegate method of the location manager to say, okay, has my authorization status changed? And if so, what to? And in our case, we want to look for, have I been authorized for always access or when in use access? And if so, we have to, in our particular case, say, is my device, in my case I've got an iPhone 6 here, is my device capable of looking for iBeacons? Because not all of them are. It requires Bluetooth 4, I think. So not all of them are, but my one is, so I'll say it's able to. And then if I can look for beacons, there's one further check. Am I able to range for beacons? Beacon ranging is like a submarine ping. It says, am I able to figure out how far this thing away is based on its signal strength? And if it can, then we can start doing our work, because our app is, of course, all about ranging, about showing distances to beacons. So this is all done using a method on the location manager called location manager. Did change authorization status, like that. And we can write some code in here. Now you'll get a status back in here, which will either be .authorized always or when in use. And you can see this by just typing in the full name. So you can do CL authorization status .authorized always, authorized when in use. And I'm going for I think when in use I went for, right? There we go. So if it's come back, yes, by all means, use my location, but only when the app's running, which is fine. Then I'm going to say, am I able to look for beacons? And that's done by saying if CL location manager, like that, is monitoring available for class. Am I able to look for a particular kind of location region? And I want to say CL beacon region .self, like that. And that refers to an iBeacon. If this returns true, it means, yes, we can definitely spot iBeacons. We're able to spot iBeacons. And then I can say, if CL location manager is ranging available, we're able to start ranging this device straight away. So we can say, great, let's see how far away from this thing. So at this point, we start doing our cool stuff, right? This point mostly works inside the simulator, but of course it cannot do iBeacons correctly, so this bit will fail. And that's fine. You do need to have your device plugged in and ready to go at this point. So I do suggest you switch to your device in the target menu here and make sure your code runs on your device now before continuing. If you're still here, I assume it means you continue. So this is where it gets interesting, because we have to now start looking for beacons, and beacons are identified by a few different things. Firstly, they have a universally unique identifier, UUID, plus a major number and a minor number. First number is a massive long hexadecimal string that's unique. Like you can go to your Mac terminal and you can run a program called Uuid Gen, and that's what it looks like. This just generates one randomly, basically, because they are pretty much guaranteed to be unique. And these are massive, so they're so big and so complicated it would take someone intentionally trying to spoof it to choose the same one as you. That identifies a beacon. The major number lets you subdivide within the UUID. So let's say you were a head of IT for a massive supermarket chain. You would say, that is our UUID. That is the Walmart or Tesco, whatever it is, UUID, that thing there. You give that same identifier to all your beacons. You buy, 50,000 beacons. You give them all that UUID. And they all say Walmart, but that's what it means. That's your number there. The major number can be used, it's a value between 1 and 65,000, to identify individual stores. So number 1 might be your London store, number 2 your Glasgow store, number 3 your Cardiff store, number 4 your Belfast store, and so forth. So this is your number, the same across all your stores. The major number you can use to subdivide inside stores. 4 stores. You can say, city by city by city by city, Paris, Berlin, whoever. The minor number can be used to subdivide the major number. So stick with me here, this is important. This thing says, I'm inside, let's say, Hudson's awesome shoe shop. Major number 15 means I'm inside Hudson's shoe shop, Bristol. And minor number 10 means I am in floor 3 in the flip-flop section of Hudson's shoe store, Bristol. So this big long number says you're in Hudson's shoe store. The major number says you're in the Bristol version, and the minor number says which floor you're on. For example, it's down to you how you use them. You can actually ignore minor and ignore major if you want to, and just use UUID if you want to. It's down to you. But it lets you be very, very precise, because beacons are so cheap. You can get them, for $10 a shot now. They last for, like I say, a year or two at a time. So you can just buy 10, stick them around your house, and say, there's one for my lounge, one for my kitchen, one for my big bedroom, one for the bathroom, one for, my drawing room, depending how big your house is, one for the patio, and you can use the same UUID for all of them and just use the major number to distinguish between them, and iOS will just spot them all. It's not a problem. So, I'm going to use a particular UUID, and this is chosen because it's built into the Locate Beacon app that you should already have installed. I think I have it on my phone here. I can show it to you just briefly. Locate. And I can go to iBeacon Transmitter, and you'll see Apple Air Locate 5A4 BCFCE. That's the one there. That's its long number. I've already put it into a text edit document here. There it is. That's its long number. And I've given it major number 123 and minor number 456. That's what I'll be using to configure my beacon. You can use your own numbers, but if you want to use Locate Beacon, you must use one of the built-in scannable beacons, because Apple are very funny about letting people edit beacons. So we're going to write a new method, and it's going to start scanning for this beacon, 5A4 BC FCE, 1740E 4BAC A814 092 E77 F6 B7 E5. That exact beacon with major 123, minor 456. Right, let's go. Func start scanning. So I'm going to make a UUID out of this, and this actually lets you, requires you to use the NSUUID class. We actually used that before, if you remember, in our names to faces application to generate random numbers to save file names as. But we'll use it here in the other way to convert a string to a UUID. So we'll say let UUID equals NSUUID, then create it with a string. I'm going to copy and paste the string from text edit, because if I type it in I'll get it wrong, guaranteed. Boom. That's my string. You should do the same thing on your own machine. Then I make a CL beacon region object from it. This takes the UUID, a major number, a minor number, and an identifier. And the identifier is some text you could enter in to identify it more nicely than 5A4 BCFCE. So let's go. Let's do let beacon region equals CL beacon region. And you see it wants all this data here, which is great. As I said, you don't have to give it a major and minor. You can just give it just a UUID or just a major. I'll do both. Just you've got maximum options that way. So I'll use UUID for my UUID, Major is 1, 2, 3. Minor is 4, 5, 6. And identifier is going to be my beacon. Call it whatever you want. Doesn't matter to iOS. Then all I have to do is ask iOS to start monitoring for it. So I can say location manager dot start monitoring for region. And then I'll pass in beacon region. I also want to start ranging as well. So I'll say location manager dot start ranging beacons in region. I'll do beacon region again. So with that in there, this is able to have iOS look for the beacon and start telling us how far away it is. What I have to do is replace this do stuff call with start scanning. That's it. Now at this point, you do need to run on your iOS device, and you do have to have the Locate Beacon app running on another iOS device. I have an iPad next to me, which is running the app. So I can launch, I'll choose my phone. If you're wondering, Jules comes from an old game called Cannon Fodder. I'll press play to launch my amazing application. It's thinking, there we go. And then on my iPad, I can run the Locate iBeacon app and start transmitting. So I'll transmit that same beacon, 1, 2, 3, 4, 5, 6 on. That's it. It's now transmitting. My phone is now detecting it, but we aren't seeing anything. Now, I'm not seeing it on my screen, neither are you. And the reason for this is because we haven't told it what to do. We've just said, hey, look for the beacon, please. That's it. The next step is to say, what is our current distance to the beacon? Because we don't actually track that whatsoever, which is, of course, not good enough. What we're going to do, like I said, is to track inside our app the distance between a beacon and an iPad. And to do that, we're going to have a new method called update distance that takes a proximity, so unknown, far, near, or immediate, and then updates the screen to show the distance. We'll change the background color so it's either gray for unknown, blue for far, orange for near, or red for immediate. So getting red hot to get closer technically. And then we'll change the text as well from unknown, far, near, or right here. So this should look like this. And in fact, what I'm going to do is I'm going to wrap this whole thing inside a switch case because that makes it easier to read. I'll also wrap that switch case inside an animation so it'll actually move smoothly between grey to red, to orange, to blue, whatever it needs to do. It's much nicer than just making it jump. So func update distance. This takes a distance, which will be a CL proximity, like that. This thing, if you have a look on jump to definition, will tell you the four things: unknown, immediate, far, or near. Immediate, again, is literally just inches away, or the device has to be touching some of the times. Then we'll say UI view.animate with duration. So this is going to just simply animate from the current background color to the new background color. I'll do a second, which looks quite nice. Then, using trailing closure syntax, I will say unowned self in, like that. And then switch distance. So what is our current distance value? If it is dot unknown, then I want to do self.view.background color is UI color gray color. Remember that self is required. We are in a closure here. I'll do self.distance label.text equals unknown. No idea what this thing is. Then I'll just copy and paste that a few times because it's much easier. If it's far, if it's near, if it's immediate. So we'll do far, near, immediate. Oops, immediate. Great. I spelled text wrong too. Don't spell text wrong, your code will not work. This one should be far, this one should be near, and this one should be right here, dude. For colors, like I said, let's start off with a sort of deep blue color. Deep blue color. Try it again. There we go. Blue color. Then we'll have an orange color. Then we'll have a red color. Boom. So those are our possible keys here. You'll notice that the switch case is not saying this is it needs a default case because there are only 4 values for CL proximity, and we're covering all of them. So Swift says, don't worry about it. You don't have to default case. I can see it's complete as it is. So this thing takes a CL proximity and lets us update the screen to reflect how far away it is. It's whinging because I have not closed my animation block. There we go. So all we have to do now is detect from the CL Location Manager when it has managed to range a beacon and update the distance. This is super easy to do. Now, I just want to point out the method calls here. The first one is start monitoring for region, i.e., I'm looking for this particular region, let me know when you see it. The second one is start ranging beacons, plural, in region, because there could be multiple beacons transmitting the same data. If you think about it, if you want to use major and minor, if you just cared, this person is in my house, in my shop, in my, museum, where it happens to be, you might have 20 beacons, all the same UUID, no major, no minor, just the same UUID. As a result, you might get multiple beacons back, all saying, yep, here I am, here I am, here I am, and actually it's the same thing each time. So we'll get a multiple things back from the location manager. It'll tell us, I found all these beacons in this region. And that's done using a new method called location manager. And we're looking for did range beacons in region. Press enter to fill in all the code. There is quite a lot in there. And this is really straightforward. We're going to get an array back. You see it's any object, but there are just CL beacons, which is a new class. We'll get an array back, and we can say, does that contain the object? Yes. Grab the first one, say how far away it is. Now, you could be more clever. You could say, find the one that's closest, but, I only have one beacon right now. It's my iPad, so it's not too difficult to do. So we're going to say, if beacons.count is greater than 0, as in we found any beacons whatsoever, then let beacon equals beacons.first as CL beacon, like that. Pull out the first beacon in the array. Then we'll say update distance, using beacon.proximity. So it'll tell you how far away it is. It's that simple. Else we had no beacons found. We'll say update distance with .unknown. We've got no idea how far away this beacon is. And that, remarkably, is the code. It's really, really simple. I'm going to go ahead and press play on my device again once it finishes copying the Swift standard libraries. That's a long time doing that. Come on. Play. Let's see if this works. I'm hopeful it works. So unknown, because the beacon is turned off. I'm going to switch it on now. And all being well, it is still unknown. Let's see if it's actually ranging any beacons. We can click on this thing here and ask it what it's up to. Yeah, it's literally finding no beacons. Cool. Let's run that back again. Make sure start is being called with a breakpoint. See, start scanning is never being called. I have muffed this up somewhere. That's okay. That's okay. I'll fix that now. I'm going to check for here. Did change authorization status. This is a good example of breakpoints in action here. So it's found a status. And it's telling us authorized always. Yeah. So if you remember, I ran the app earlier to show you the terrifying warning message of authorize always. And I have since then changed the code to use when in use. Now you could of course check for both. I am not. I'm using just when in use. So why I'm going to put this back to authorized always. That is my bug. That was a fairly simple bug. Good. Coding on a screencast, you usually get some pretty terrifying bugs, as you've seen so far, because you've made a mistake somewhere. And that's what's happened here. So I will just put in that change here, make this check for authorized always. You could, of course, just do both. So if you were using both, for some reason, you could just do both like that by using a pipe symbol when in use, like that. Now I'm checking for both. Let's try that again. There it is, authorized when in use, sorry. Okay, let's try that again. I'll turn the beacon off on my iPad. I will wait for it to finish building the product. I will press play on the device. Run. Come on, you better work. Massive climax, and yeah, that's working correctly. So I'm going to disable that breakpoint and spin on. And here we go. I'll press it on my iPad. Fantastic. It's gone right here straight away because my iPad is very close to my phone. I'll try and put my iPad further away from my iPhone, and you can see it's gone back to near. So it's recognized my device has got further away. I can't really get much further away without breaking my arms too much. But as you can see, it is correctly distancing the beacon, saying near or right here. If I'm working very hard, there we go. I've managed to go blue. I've put my iPad behind my back now and attempt to get it to be further away. So because of the low energy, the nature of Bluetooth, low energy, this includes the name, it is thinking it's very far away when it really isn't. But I can bring it back from behind my back. Hopefully you'll see it. There we are. Animate back to right here straight away. with a nice sort of fade as well, thanks to the UI view animation. So that is it. That's the end of the project, believe it or not. That is iBeacon ranging done with a very simple project. You might not need ranging. You might just want to say, is the beacon here or not? In which case, just check for any beacons existing, and you change this thing, here. If it is far, near, or immediate, the beacon's present. Do something. And what it is that, of course, down to you. It's your application now. Go ahead and make something cool with it. Hopefully you've seen how easy it is. It really is very easy. Just don't make the mistake I do and try and mix and match with always and when in use. You just choose one, stick with it, use the right key in your property list, and you'll make your life so much easier. Okay, for more information, see the website hackingwithswift.com, where you can buy this video and see my fantastic status errors in high resolution. You can also buy it as an ebook where I don't make the same mistake, fortunately. It costs just $3 a pop, and your support does help me make more videos like this one. You can also find me on Twitter. I am @2straws. If you have problems, suggestions, feedback, get in touch, follow me there, and I'll do my very best to help you.